Lesson 5D, we're going to look at how to factor binomials. So that is things with two terms. All right, so there's these are called special cases. So there's two different special cases that we can look for. One of them is called a difference of squares. And so for it to be a difference of squares, we have to have two terms with subtraction in between. So it has to be subtraction. And then both terms must be perfect squares. Remember, perfect squares is anything we can take the square root of and get a whole number answer. So for variables, we're looking for an even exponent, and then here we're looking at something that a number times itself equals that. Okay, so both of these are perfect squares. There's two terms, there's subtraction, it meets all my requirements. So here are the steps. First thing I'm going to do is take the square root of each term. Okay, so the square root of x squared is x, the square root of 9 is 3, and then when I write my two factors, one is adding those two terms, and the other is subtracting those two terms. Okay, and that's it for different squares. That's a process. Take square root, one's plus, one's minus. Okay, we're going to look at this example. So it looks a little bit different, but let's see, does it meet our requirements? We have two terms with subtraction. Are both terms perfect squares? Well, 9 is a perfect square, x squared is a perfect square, so we're good there. 16 is also a perfect square. All right, so even though it looks a little different, this still works. It still fits our process. So square root of each term. Square root of 9x squared would be 3x. Square root of 16 would be 4. So my two factors are 3x plus 4 and then 3x minus 4. Okay, over here, 3x squared minus 12, remember that I told you the first rule for any factoring problem was to look for a GCF. So 3x squared and 12 have a 3 in common. Okay, so if I factor out that 3, that leaves me with x squared minus 4. And then what we need to do is check what's left over in the parentheses. Can this be factored further? Well, x squared minus 4 meets my requirements for a difference of squares. Two terms, subtraction, they're both perfect squares. So I'm going to factor this further. Okay, the square root of x squared is x. The square root of 4 is 2. So I have an x plus 2. An x minus 2, and then I'm also going to bring this 3 down, and it has to hang out there, and that would be my final answer. So remember to check for that GCF first if it doesn't meet your requirements at the start. Okay. The other kind of special situation that we're going to look at is called a sum and difference of cubes. All right, so this just has to be two terms. It can be plus or minus. Okay, and then they both have to be perfect cubes, meaning I can take the cube root of each term. So there's a formula that we need for this. Okay, and there's the formula, a plus or minus b, and then a squared plus or minus ab plus b squared. Okay, that plus or minus part, you're going to pick one, and and this is where we use the acronym SOAP to help us remember. So it stands for same, opposite, all right, and then always plus. So when I write my factors in, the first sign is going to be the same as the problem. The second sign is going to be the opposite of the problem. And the third sign is always going to be plus. Okay, so we'll go through this one. I'm going to take the cube root of each term. So the cube root of x to the third is x. The cube root of 27 is 3. Okay, so now these are my a and b. Okay, so everywhere in this formula that I see an a, I'm going to replace it with an x, and everywhere in this formula that I see a b, I'm going to replace it with a 3. Okay, so my first set of parentheses is a, which is x, and then I need the same sign, so same as my problem, so plus b, which is 3. All right, and then my second set of parentheses, a squared, so that's going to be x squared. The second sign is the opposite, so minus. All right, a times b, so x times 3. The last sign is always plus, and then it's b squared, so that would be 3 squared. Okay, and then what we're going to do is we're going to simplify these things. So x plus 3 is simplified. Okay, x squared is simplified. X times 3 we don't usually write like that. We usually write the number next to the variable. So I'm going to change that to 3x. And then 3 squared I can simplify to just 9. So this would be my final factored answer. Alright, so sum and difference of cubes. You need to know this formula, alright, and use SOAP to help you remember what signs go where. And that's it for factoring binomials.